everybody, in this video we're going to talk about how to find the volume of a pyramid. So we see at the top in this blue box our equation. Volume is equal to 1/3 capital B H, right? So that's area of the base times the height of the pyramid. And the reason why this is the formula is in this sentence down here in red. It says the volume of any pyramid with any base is equal to 1/3 of the volume of a prism with the same base and height, because you can divide any polygon into triangles and any pyramid into triangular pyramids. So we looked at dividing any polygon into triangles when we found the interior angle measures of a polygon earlier in geometry. And so essentially this is the reasoning why we have that 1/3 in our volume formula here for a pyramid. Because remember, the volume of a prism was just area of the base times height. So here we have 1/3 times the area of the base times the height for our pyramid. Okay, so we're going to look at 3 examples where we find either the volume or the side length of the base of the pyramid or the height of the pyramid. And then we're actually going to do a couple examples where we have some composite solids that involve pyramids. So for number 1, we want to find the volume, and we are given the one of the side lengths of our base, and also the fact that it's a square pyramid because we have these congruent tick marks here. And also we are given the height of our pyramid. So we can go ahead and write our formula. Volume is equal to 1/3 times the area of the base times the height. So we have 1/3 in there. And then our base here is a square pyramid, so the area of the base would just be length times width. So that would be 4 times 4, which is 16. And then our height here is 2.4 meters. Okay, so now we can go to our calculator and we can type this in. So I'm going to do 16 times 2.4, and then I'm going to divide that by 3. And we get a volume of 12.8 cubic meters. Okay. All right, for number 2, we're going to find the side length of the base. So we are given the volume and we are given the height of our pyramid. So we can go ahead and write 75 is equal to 1/3 times the area of the base times our height, which is 9. So now on the right side, if we multiply 9 times 1/3, that's going to give us 3. So we have 3b. And now we can divide both sides by 3. And so now we get a capital B is equal to 25. Okay, well, if we look at our diagram, we once again have a square pyramid. So if the area of the base is 25, that means length times width is equal to 25. Well, for a square, we know the length and the width are the same, right? So instead of saying length times width, we could say side squared. And now we could take the square root to find the side. So this is equal to 5. And so we could say the side length of our base is 5 centimeters. All right, and for number 3, we want to find the height of the triangular pyramid. And so we are given the volume and we are given some information that we can use to calculate the area of the base. So we can go ahead and say volume 384 is equal to 1/3 times the area of the base. Now here the base of our pyramid is a triangle. So the area of the base, remember, is going to be 1/2 times the base times the height of our triangle. And then we have times the height of our pyramid, right? Which is another h, which we don't have this h right now. That's what we're trying to find. Okay, so now we can write this as 384 is equal to 1/3, and then in parentheses we have 1/2. The base of our base, I know that sounds kind of funny, but the base of our pyramid here is a triangle. And the base of the triangle here is 24 meters. And the height of our triangle is 8 meters. So now we can simplify in these parentheses. And so we have 24 times 8. And then we're going to divide that by 3. No, sorry. We're going to divide that by 2, right? 192 divided by 2. So now we have 96. So we have 1/3 times 96 times the height. And now we can multiply 96 times 1/3. Okay. All right, so that gives us 32. So we have 384 is equal to 32h. And now we can divide both sides by 32. So 384 divided by 32, and we get a height of 12. So we're working with meters here. So we're going to say our height of our pyramid is 12 meters. So be careful on that one. We did have a 1/3 and a 1/2 in there. So I made the mistake of multiplying by 1/3 when we were working with just the area of the base. So don't let that happen to you, right? Okay. So now for our composite solid examples, we're going to find the volume of our composite solid. We've done a previous video on composite solid, so I'll link that in the cards right now. But we're going to look at 2 examples that specifically deal with pyramids. So for number one, notice we have a cube on the bottom. How do we know it's a cube? Because we have or not a cube, but we do have a square base, right? It's not a cube because this right here is not 12, but we do have a square base. And so now we want to find the volume of our cube, or excuse me, the volume of our, I guess we could call it a rectangular prism, and then the volume of our pyramid that is stacked on top of our prism. So for our bottom shape, we're going to say volume is equal to length times width times height. So this is going to be 12 times 12 times 9. And so we have 144 times 9, and that gives me 1,296. And this is cubic meters. Okay, so put a star here. This is one of our volumes that we need to add together. Okay, now we have a pyramid on the top, and we are given the slant height of our pyramid. Well, we know for our pyramid, we have volume is equal to 1/3 times the area of the base times the height. Well, we do have the area of the base because we just found that. It's 12 times 12. That's our base because it's a square. So now we can go volume is equal to 1/3 times 144 because we're doing our square base of our pyramid is 12 by 12. And then times the height. Well, we don't know the height yet, but if we think about drawing a right triangle in here. So if I make this a right triangle, okay, and that now the slant height is 10. That is my hypotenuse of this triangle that I just created, okay? And so now if we think about this distance that we just made here, that would be half of one of our sides. And so since the side of our base was 12 meters, this side would be 6 meters. And now we've created a Pythagorean triple. So that means our height here would be 8 meters because that's a 6, 8, 10 Pythagorean triple. And so now we can plug that in right here for 8. Now we can do 144 times 8. We can divide that by 3. So we get a volume of 384 cubic meters for our pyramid. Now what we're going to do is we're going to add these two volumes together so that we can find the volume of the composite solid. So we'll add 384 to 1,296, and we get a composite volume of 1,680 cubic meters. All right, and for number two, last example we will do, notice we have a triangular prism and we have a pyramid on top of that. So for our triangular prism, we are going to once again do the area of the base times the height, but in this case, we have volume is equal to our base now is a triangle. So this is going to be 1/2 times the base, which is 8, times the height, which is 4, and then times the height here, which would be 5. Okay, so now we have volume is equal to, this would be 16 times 5, which is 80, and this is going to be cubic feet. Okay, so we'll put a star by that for now. That's one of our volumes, right? We'll go ahead and circle that. Now for our pyramid that's on the top, we're going to once again do 1/3 times the area of the base times the height. So volume is equal to 1/3. The area of our base is going to be the same thing here. We have the same shape at the bottom. So the area of our base was 16, and now the height of our pyramid is 3. Okay, so now we can take 16 times 3 to get 48 and divide that by 3 to get 16, and that is 16 cubic feet. And now we can add those two together to get a composite volume of 96 cubic feet. Okay, and that's how you find the volume of a pyramid.